In this video, I'm going to go over data augmentation, where we can create more data from the data that we already have. Firstly, I'm going to briefly go over the artificial intelligence pipeline. We start off collecting data. Maybe somebody else has collected the data and we can steal it to use ourselves. Then there's usually a pre-processing step where we do some alterations to the data so that we can better train our network. Then we do some sort of classification. So for my case, I mostly focus on the neural networks and the deep learning. And finally, we're going to evaluate it using whatever metric is going to be relevant for that specific task. So data augmentation is very much a pre-processing job. And here I'm just going to focus on this additional data generation point. So these sorts of things are usually more relevant, not always, but usually more relevant to the traditional neural networks. We're focusing on creating more data because deep learning frameworks are usually extremely data hungry. So the more data that you've got, the better it is going to be for you. In terms of data generation, I'm going to talk about some of the more advanced frameworks in artificial intelligence in lecture 6. So there I'm going to talk about generative adversarial networks, which can generate high quality new data from scratch. For this video, I'm going to focus on making alterations to data that we already have. So one of the reasons you might want to do this is maybe you have data that is imbalanced. Let's say you're trying to detect a rare type of cancer, and for every 1,000 images you've got, this cancer is only present in one of those images. So maybe you would want to take the image of the rare cancer that you've got and make a few different copies of it, so that can help your network. It gives your network more examples of that cancer to learn from. So this is something that can be very, very important. But it doesn't have to be that specific. In general, more data is going to be good for your network. So yeah, neural networks usually perform better with more data. So we can create more data from the data that we've already got. That's what I'm going to explain here. Let's say we have this image of a cat. We can do a lot of things with this image. So we can create, with lots of these transformations, we can create lots of new images that are of the same identity to give us more data. So these include horizontal flipping, padding and cropping, enlarging and cropping, rotating, and combinations of all of those transformations. The way that we would do this is, remember we have a data set X, and we have labels Y. So there is some perfect real world function F star, which will take you from your data to the labels. So in this case, maybe this is animal 1, let's say 2146. That's the input data, and the label is just going to be cat. Okay, and so this is going to be small x, and x is going to be an element of the data set. And we train a neural network F that is going to be as close to f star as possible. So this f is going to be the neural network that we're trying to train. And all you will do is, with these additional samples, they will all have the label cat. So you can just add all of these additional animal 2146 underscore 1 underscore 2 underscore 3, and you give all of these images the exact same label, and then you can just put them all into your data set. So that's a reasonably straightforward way that we can use data augmentation. I'm going to explain something a little bit more complicated later, but before we move on to that, let's talk about some different ways that we might augment data. So this is something called random erasing, and this has been shown to be very, very useful. It often improves performance. All we do is erase or replace some image pixels with either zeros or something 0.5s or even 1s, or just complete random noise like we have in this case. And again, we do the exact same thing. Instead of training just with this one, like the full original image, we train with the new image that has been augmented. So in this case, what you do is slightly different. You don't just put these into the initial training set. What you would do is you start off with this image. I'm going to call this image X now. And then you do some erasing. So you're going to erase some portion of the image, either by turning pixel values to 0 or having this random noise here. And then you're going to get a new image X prime. So let's say that that is this one. And then you put this through your neural network, try to get a label, and then finally you back propagate through this one. The next time that you try to learn from this image, you're not going to use the same augmentation, but you will instead use a different augmentation. So now maybe we'll use this one instead. So this is going to change every time you go forwards and backwards through your network. So for each iteration. Lastly, there's so many different things that you can do to mess around with your images. You can do some color casting because quite often you'll have the problem where you have slightly different lighting conditions in different images throughout the data set. So by adding slight tints to the color, you can create a more varied data set to be able to handle those color variations. Or you can do something like this patch shuffle technique, where you split your image into these 2x2 patches, and then you just reorder the pixels randomly, but keeping those patches intact. So you can see that this 1.3 here is going to stay within this blue part of the transformation, but it'll be in a different position. So sometimes your random reordering, as is the case with this green box, is going to be exactly the same as it started with, but usually not. I'd say that these two types of augmenting data are less common. More common are the transformations that we saw before and the data random erasing. So this is something that has become more common in the last few years. Something called self-supervision. So yeah, really in the last 1 or 2 years, I'd say that this has become much more standard way to train your networks where you do an extra step. So if you want to get like top marks for your iterative development stage, this is the sort of thing that you might try to accomplish. What is going to happen with self-supervision is that you're going to do all of these augmentations, but you're going to add an extra step. So now I'm going to say that these augmentations are going to be in a set called A. Right? So it's all of these. And what is going to happen is that these are going to have the label of animal 2146. So you don't train them that the animal is cat. Instead, you have a new label that the animal that is the identity of the subject in the training data. So what you do now is essentially for each of these, you try to match them to the label animal 2146. So you do A to this dataset X. So you're trying to create a neural network to go from your augmented data to your original data, or to the same label as your original data. And you're actually going to use the same neural network as before, or convolutional neural network. The idea is that this is some pre-training so that when you come to actually work out the label that this is a cat, in this stage, if I go to highlight, yeah, so when you try to do this stage, you've already pre-trained it to learn that these augmentations are similar to the actual input data that you have, and this seems to make the network a lot more powerful when it comes to just trying to get from this input data to the labels. So that's a bit more advanced, it's more new. Feel free to try it if you want to move towards getting top marks in your projects. That's going to be it for this video, so I will see you in the next one.